Okay, here's what you missed last class. What we did is you'll need to take some notes over this geometric series information. There will be a new formula that I'll need for you to add onto your note card. Write it carefully and watch my examples, because the hardest part of what we do today is just calculator work. It's broken down into two different pieces today. There's going to be one piece where I show you what I mean by expand, just like we did in the arithmetic, but it's in the geometric. And then there's going to be a second part where I show you how to use the new formula. You also missed some whiteboard review, so you'll need to get a copy of that and get that done for me if you want those points. Right now they're sitting as a 0 on the computer. And then I'll also give you worksheet number 6, which is the geometric series information. So here goes. Take a few notes as we go. You can also pause this video, do whatever you need. I didn't have the class take many notes on this slide right here, because a lot of this is just the same things that we've done. What we did last class was called a geometric sequence. Remember, guys, in the geometric sequence, the formula that we used was this: G of n equal G sub 1 times r to the n minus 1. So if I was writing a formula for this, it would look like this: G sub n equal G sub 1, which happens to be 4, r, which is my r value, whatever it takes to go from 4 to 12, 12 to 36, which happens to be 3, and the n minus 1. Notice that the n minus 1 is an exponent in this. It becomes a geometric series when this happens. Notice that I eliminated the commas and I put in addition signs. That made it a geometric series. Once again, it's geometric because I'm multiplying or dividing by the same number every time. Notation is just like we had for the arithmetic sequence. If you see something like s sub 2, I'm asking you to add up the first two terms. So I'm asking you to say that 4 plus 12 equals 16. S sub 3 would mean I would like for you to go sum up the first three terms. 4 plus 12 plus 36 looks like 52. The sum of the first four terms would be the sum of the first three terms plus the fourth term. So 160. That's like number 1 on your worksheet. That was pretty easy. Now, let me remind you, when you see the word expand, when you see the word expand, that means there's no formula that you get to use. Because some of our formulas will work, some of them won't. So when you see the word expand, I'm asking you to do this. Use the numbers from 1 to 4. So 1, 2, 3, 4. Plug that in wherever you see, in this case, an x. So I'm going to have 2 to the first. I just plugged a 1 right there. Plus. Now plug a 2 right there. So 2 to the first, plus 2 squared, plus 2 cubed, plus 2 to the fourth. Now grab your calculator. 2 to the first is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. When you add those up, 16 and 4 make 20. 2 and 8 make another 10. So this must be 30. That's what I mean by expand. Plug in your numbers, write them down first, and then use your calculator. Here's my next one. 4 to the x minus 1. So you're going to use the numbers 1, 2, 3, 4, 5. But here's how you're going to handle this. Write it out and then grab your calculator. If you go 4 caret 1 minus 1, your calculator is going to tell you that answer is 3, and that's a wrong answer for us. So here's how I'd like for you to do it. Plug in a 1 right there. Do that exponent in your head. 1 minus 1 is 0. So I'm going to get 4 to the 0 plus. Now plug in a 2. 2 minus 1 is 1. So I got plus 4 to the first plus. Now plug in a 3. 3 minus 1 is 2, so I've got a 4 squared. Plug in a 4. 4 minus 1 is 3, so I got a 4 to the third, and then a 4 to the fourth. What would be in your best interest is to write them down first. Now grab your calculator. 4 to the 0 is 1. 4 to the first is 4. 4 to the second is 16. 4 cubed is 64. 4 to the fourth is 256. The Greek letter sigma means add those up. So when I add these up, it looks like I'll get 341. Okay. I got a couple more expands for you, but that's the gist of how they go. So here's my next one. 3 to the x minus 1, it's going to look exactly like the one we did. I'm going to ask you to use 1, 2, 3, 4, and 5. Do the exponent in your head. When you plug in a 1, 1 minus 1 is 0, so I got 3 to the 0, plus. Plug in a 2, and that gets a 1, so I got 3 to the first, plus 3 squared, that was 3 minus 1, plus 3 to the third, plus 3 to the 5 minus 1 is 4. That's what it looks like so far. Now let your calculator help you out. 1 plus 3 plus 9 plus 27 plus 81. Add those up and get 121. Okay. I've got one just a little bit harder than that one. Here's what it looks like. This one looks scary. What you cannot do is you can't go 4 times 2 is 8. You can't do that. So I've got that out of the way right off the bat. That's something that you can't do. But what I'm going to do is go 4 through 8. So I got 4, 5, 6, 7, and 8. I'm going to plug in a 4 right here. 4 minus 4 is 0. So here's what we need to do. This becomes 4 times 2 to the 0. Don't call that 8 to the 0. Plus, I've used a 4. Now if I plug in a 5, 5 minus 4 is 1. So this becomes 4 times 2 to the first. Plus, now plug in a 6. 4 times 2 to the 6 minus 4 is 2. Plus, 4 times 2 to the 7 minus 4 is 3. Plus, 4 times 2 to the fourth. So notice that, guys, I've left everything the same. 4 and a 2, 4 and a 2, 4 and a 2, 4 and a 2, 4 and a 2. My exponents went 4 minus 4, 5 minus 4, 6 minus 4, 7 minus 4, 8 minus 4. Now grab your calculator. 4 times 2 to the 0 is 4. 4 times 2 to the first is 8. 4 times 2 squared is 16. And then 32. And then 64. Add those up and you'll get 124. I'll do one more of these. I don't know that you'll need it, but I'll do one more of these, and then I'll move on to the formula. Once again, guys, the same thing. I'm asking you to use the numbers 3, 4, 5, 6, and 7. To take care of this now, do the exponent in your head. Every one of these will have a 5 times 2 to the something. 5 times 2 to the something. 5 times 2 to the something. Let's go get those somethings and see if I need more. 3 minus 3 is 0. 4 minus 3 is 1. 5 minus 3 is 2. So it looks like I need some more. Plus 5 times 2 to the third, and 5 times 2 to the fourth. Grab your calculator. This becomes 5. This becomes 10. This one becomes 20. This one becomes 40. This one becomes 80 for an answer of 155. Okay. Those are 5 examples. I did 3 in class, so there's 2 extra here. But that's how we handle it if it says expand. Now, if I ask you to sum up the first 20, I'll give you a formula for that. On this screen right here is a formula that I need you to put on your note card. So I'll have some awkward silence here on a video. It seems like I'm wasting some time. But I'll have some awkward silence. But here's the formula that I need you to put on your note card. And by that note card, put geometric series. I feel like I should sing the Jeopardy music or something. Hey, but in this formula, make sure you see some little things. G sub 1 is the value of the first term. R is our R value. It's to the nth power, and then the minus 1 is not in the exponent. Last time, we had another formula that looked like this. That exponent was n minus 1. This exponent is just n. Other key things that you need, make sure you have everything in parentheses. I'm going to assume you have that on your note card. If not, I'm going to rewrite it on the next slide, so don't panic. But you need to write this example down. That way you have a few in your notes. And remember, guys, it's your note card. If you want to put an example on your note card, do that. If you need to pause the video to write something down, that's okay too. But some things that I know. As soon as I see the plus signs, I know that this is a series. Since I'm multiplying by 2 every time, I know it's geometric. One key thing is I need my R value. So R is 6 divided by 3, which is 2. It's always your second term divided by your first, not your first divided by your second. One other thing that I know, R should be bigger than 1. Since these terms are getting bigger, R is 2. But here's what it looks like. Here's our formula. S of n equal G sub 1, R to the n minus 1, over R minus 1. I'm going to plug in the numbers that I know. So it's going to look like this. G sub 1 is 3, so I got 3 parentheses. My R value is 2, so I've got 2 to the 15th minus 1, close my parentheses, divided by parentheses 2 minus 1. Now you might be thinking, Mr. Harris, I know that 2 minus 1 is 1. Then go ahead and put a 1 there. But if you don't do this in your head, guys, you need to put it in parentheses. When you type this in your calculator, it's going to look like this. 3, some of you will have hit times, parenthesis, 2 caret 15 minus 1, close your parentheses, divided by parentheses 2 minus 1 equal. Take a second and run this through your calculator. I'll pause for just a second, but you should get 98,301. So I'll pause for just a second. Make sure that you can use your calculator to run that through and get 98,301. The key thing today is calculator work. If you can't get your calculator work, write a couple of them down, bring it in, and I'll show you how to type it in on your calculator. But I've got about 6 more examples coming up, just like this one. So here's my next one. Given 2 plus 10 plus 50 plus 250 on down the road, I would like to sum up the first 20 terms. It's geometric because I'm timesing by 5. If you didn't see that, R equal 10 divided by 2, which is 5. Second term divided by your first term. So to sum up these first 20 terms, it's going to be G sub 1, which is 2, times. So there's a parenthesis. My R value, which is 5, raised to the 20th power, minus 1, close your parenthesis, divided by parenthesis 5 minus 1. You have to have parentheses down here, or you got to do that in your head. Either one works for me, as long as you get the right answer. Hit pause on the video. Run that through your calculator, and you should get approximately 4.77 times 10 to the 13th. It's a big number. But man, if you look at how these numbers are growing, times them by 5 every time, I'm up over 1,000 already. Then that means I'm up over 5,000 and 25,000. Man, by the time I get to the 20th term, it's big. So here's another one. We're going to sum up the first 15 terms of this sequence, 1,000, 500, 250. Once again, this is the formula, g sub 1, r to the n minus 1, all over parenthesis r minus 1. Let's get our r value. Some of your classmates thought r was 2, but it's not. If r was 2, then I'd have 1,000, 2,000, 4,000. So let's get the correct value for r. R is going to be 500 over 1,000, which is 0.5. That's my r value. So now my formula looks like this. The sum of these 15 numbers is going to be g sub 1, which is 1,000. My r value, which happens to be 0.5, to the 15th power, minus 1, close your parenthesis, over parenthesis 0.5 minus 1. Once again, then I won't do this again. When you type this in your calculator, 1,000 times parenthesis, 0.5 caret 15 minus 1, close your parenthesis, divided by parenthesis, 0.5 minus 1. If you do that, you're going to get about 1999.9. I rounded, so notice I used approximately. But that's how the story goes. I've got 3 more. I'll click through. All depends on how much you feel you need, but I'm going to pick the pace up on these last 3. So now it's going to look like this. We'd like to sum up these first 20 terms. So the sum of these first 20 terms is 600 parenthesis. I need an r value. So let me come off to the side and find my r value. R is going to be 240 over 600. The second term divided by your first term. And guys, that is 0.4. Some of your classmates thought it was 2.5. But notice my numbers are getting smaller. That means I have an r value less than 1. If you multiply by a number less than 1, numbers get smaller. So I got 600 times 0.4 to the 20th power minus 1, close your parenthesis, over parenthesis 0.4 minus 1. If you need to, hit pause on the video, but you should get about 1,000. It came out to be something like 999.998 or something like that. So about 1,000. Here's my next to the last one. Once again, my numbers are getting smaller, so I know that r is less than 1. Let me just get my r value. R equals 177 over 531, which is 1/3. Or if you'd like to use a decimal, I'll let you do that, but use 0.3333. Use 3 or 4 decimals when it's something like this. Really, decimals are easier to type in. So here's what it looks like. The sum of these first 10 numbers happens to be 531, parenthesis, 0.3333 to the 10th, minus 1, over, parenthesis, 0.3333 minus 1. If you take a second to run this through, you'll get a number that's approximately 796.49. Since we're rounding, since we're not using a fraction, guys, use 3 or 4 decimals. Even more would make it more accurate. Then I got one last example for you, and then that should teach you how to do worksheet number 6. But just some little hints. I know, once again, this is a series because of the plus signs. Whenever decimals show up out of the blue, like 0.8, 0.84, it's got to be geometric. Because if we're adding, we're going to get nice whole numbers. So let's get my R value right off the bat. R must be 28.8 over 6, which is going to be 4.8. So I got my R value. Now it's all calculator work. The sum of these 20 terms is going to be 6 parentheses 4.8 to the 20th minus 1 over 4.8 minus 1. Make sure you put that in parentheses. If you run this through correctly, you're going to get about 6.6, I'm sorry there, 6.656 times 10 to the 13th. You're probably thinking, but Mr. Harris, why did you use more decimals? I didn't want to write 6.66 times 10 to the 13th. So I decided to add in an extra decimal. So that's what we did. That's what we did today while he was gone. On your worksheet number 6, number 1 is that S of 2, S of 3, sum up the first 2, sum up the first 3. Your number 2, 3, 4, and 5 is the expand. So that means plug in 1, 2, 3, 4, 5, or whatever I gave you, write out the numbers, and then add them up. And then the rest of them we'll use this formula. Watch the video. Good luck on your assignment.